Assalamualaikum warahmatullahi wabarakatuh. And very good morning to everyone. Today we will present about the application of Laplace transform. So we are from group 2 in section 10, and my name is Nur Hamiza binti Hafiz, CF210308. So this is content of the presentation. The first one is the introduction. Number 2, problem solving, discussion, conclusion, and the reference. The first one is the Laplace transform is an integral transformation that is often used in mathematics with many applications in science and engineering. The Laplace transform also be interpreted as a transformation from the time domain where inputs and output are function of the time to the frequency domain. Okay, third, the Laplace transform method plays an important role in the modern approach such as analyzing and design in engineering system. Okay, the last one is the Laplace transform is helpful in a solution of the ordinary differential equation describing the behavior of system. We go to the background study. Okay, based on the Dugus 2002, they used the Percival element method to deduct the frequency and vibration mode equation for any and multi-span beam cross-section. It seemed like a Giley 1992. They used the Laplace transform formula to deduct the frequency equation of the continuous beam and obtain the frequency equation and variable mode equation for the simple two-span beam with a same span length. Okay, the third one is from the Liao 1995. They used the dynamic stiffness method to systematically study to the vibration and various continua. And the last one is S.Z. Young in 2009. They used the Laplace transform used to the transfer metric method to deduct the continuous beam free vibration capital, then provide a method of the obtain of eigenvalue and state the relationship between bearing number and stiffness of influence on the existing frequency of the continuous beam in his.
Hi, I'm Muralidharan Suresh. I'm going to present about the problem statement. Structural analysis is a branch of solid mechanics that uses a simplified model of solids such as bars, beams, and shells for engineering reasons. The main goal is to determine the impact of loads on the structure of the building and its component. In contrast to elastic theory, the model used in structural analysis is often a differential equation on spatial variable. The structures that are the subject of this type of analysis include buildings, bridges, planes, ships, and anything else that need to withstand loads. Structural analysis uses the ideas of applied mechanics, material science, and applied mathematics to calculate the structural deformation, internal forces, stresses, supporting reaction forces, speeds, accelerations, and stability. The results of the analysis are used to verify the maintainability of the structure. This often makes physical testing impossible. Therefore, statistics is an important part of the engineering plan for supporting structures. In context of structural analysis, a structure refers to a body or system of connected parts used to support a load. Important example related to civil engineering include buildings, bridges, and towers. And in other branches of engineering, ships and aircraft frames, tanks, pressure vessels, mechanical systems, and electric supporting structures are important. To design a structure, an engineer must account for its safety, acoustics, serviceability while considering economic and environmental constraints. There are three objectives of our project. Firstly, the improvement of scientific method of evaluation, the usage of Laplace transforms as carried out to fundamental beams, symbolism and terminology well suited with backgrounds in structural engineering. Second, the improvement of general solution to fundamental beams, which can be subjected to any transverse machine of distributed loads, concentrated loads, and applied moments. And lastly, the use of the Laplace transforms technique as a primary device of evaluation in impact investigations. Thank you.
Assalamualaikum and good afternoon. My name is Ms. Shafika and today I'm going to present on chapter 2, problem solving. So the problem that we choose is by using the Laplace transform, find the deflection of function yx of the beam subjected to partially uniformly distributed load as shown in figure 1. The first thing is we differentiate the terms and apply the load function. Then we use differential equation for the solution with the form to get the second equations. Next, by following the end boundary condition at x equal to 0, we got 0 deflections and 0 slope for the bill and support. And at x equal to L, we got 0 bending moment and 0 shear force at the free end.
Hi, my name is Surya and I'm going to continue the solution part. The equation from the deflection function yx in equation 1 will thus become d power 4 y4 over dx power 4 equals to w over x over ei times ux minus L over 3, which is equation 7 where the x is bigger than 0 and also greater than L. This deflection function yx in equation 7 together and with the condition in equation 3 to 6 where we get equation 8 and 9. The equation 9 will be load to the following expression ys to be, where the ys is equal to c1 over s power 3 and c2 over s power 4 and w over ai s power 5 bracket 1 minus e power s L over 3, where the c1 value represent for y second derived of 0 and c2 value will be y third derived 0 to determine after got solution yx. The induced beam deflection function yx equation in 1, 2 and 7 may be obtained by inverting the expression ys in equation 9, where to get the following equation 10, 11 and 12. Due to the fact that even n condition in equation 4 and 5 are at x equals to L, which allow the partial solution in equation 12 for y second derived L equals to 0 and the y third derived L also is equals to 0. The C1 value is W L over 2 and the the C1 value is W L square over 8 EI and the C2 value is equals to WL over 2 EI. So from the question we can conclude the equation for the deflection of beam yx is WL over power 2 over 16 EI x square minus WL over 12 EI x cube plus W over 24 EI x power 4, where the x value is smaller than L over 3. And another equation is also yx is equals to WL power 2 over 16 EI x square minus WL over power 12 x cubed plus w over 24 ei x power 4 minus w over 24 ei bracket x minus l over 3 power 4, where the x value will become greater than l over 3. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and good evening. My name is Intan Nur Asma Zalina binti Muhammad Ahsan Nizam. My metric number is CF210138. For the discussion of this project, from the problem statement and the problem solving, the simplest of the three methods here discussed, the mechanics of materials method, is available for simple structural members subject to specific loading such as axially loaded bars, prismatic beams in a state of pure bending, and circular shaft subject to torsion. The solutions can under certain conditions be superimposed using the superposition principle to analyze a member undergoing combined loading. Solution for special case exist for common structures such as thin-walled pressure vessels. The conclusion of our project, the Laplace transform proved a useful, more general form of the continuous time Fourier transform. It applies equally well to describing systems as well as signals using the eigenfunction method, and to describing a large class of signals better described using the pole zero method. As shown, here is a few references that we refer for our project. That's all from us. Thank you.